let's see, network operating systems. This is, what chapter is this? 8, 9? Chapter 9? Something like that. So we're going to talk about network operating systems. We talk about it really kind of from a general purpose perspective initially, and then it kind of dives into some of the specific network operating systems. Windows 2008, the Server 2008, Unix and Linux. Those are the ones that it really focuses on. So we'll describe the characteristics common to all network operating systems. What's the purpose behind network operating systems? This is to allow us access to shared resources, to control that access, to make sure that people who are using those resources have the proper authorization and that they're properly authenticated. We'll compare and evaluate network operating systems to select the right one for your network. They're not all created equal. There's a lot of similarities between them in terms of the features that they offer, but there's usually something that's unique about one that gives it an advantage over another given a particular scenario. So it's not really fair to say that one's better than the other. It really depends on the specific situation. Then we'll talk about some of the requirements for both Windows Server 2008 as well as Unix and Linux. And then lastly, it finishes up talking about creating users and groups and file permissions, all those types of things. So characteristics of network operating systems based on client-server architecture. That's why we're going to end up using a server, because we want to be able to share those resources in a controlled fashion. If we didn't have to control it, we could just use a peer-to-peer network. We wouldn't have as much control, but it would certainly allow us to do a lot of those things. But if we really want to have the ability to tightly control access, monitor what's going on, back up our data more easily, and administer our network more easily, we want to function in a client-server architecture. Network operating system manages resource sharing, provides a lot of other functions. Some of those functions are built in, some of them you have to add on with various add-on applications, or install separately the operating system. They come with the disk. As far as some of the components, they vary by the network operating system version and type. We'll see that a little bit later when we talk about Windows Server 2008. There's different versions of that, and they're really kind of geared towards specific things that you might want to use that server for, such as delivering web pages and things like that. Networks use servers exceeding minimum hardware. That's the goal anyway, you hope. It's kind of like a used car, or buying it, not a used car, but buying a car. They tell you the second you drive it off the lot that it's that you've lost half its value, or at least a significant portion. Same thing with computer equipment. The second you fire it up, the second you make that purchase, it starts to be dated already, so the value of that equipment goes down. So you really want to make sure that you're exceeding that minimum hardware. Make sure that you have additional hardware to be able to exceed the minimum requirements from a performance perspective and for an amount of time before you have to do any upgrades. Figuring out which server hardware is optimal, you need to ask yourself several different questions, because this is what really kind of addresses that issue of which one is better: Linux, Unix, Windows. There's not a right or wrong answer to that. It depends on the answers to some of these questions. So what kind of applications are you going to need to run on the server? That's going to help answer some of those questions. A big one is, what can the organization afford? If you're broke, maybe Linux looks really attractive. But just keep in mind there's other trade-offs as well. So, determining optimal server hardware. Continued. Applications influence the type of application, resources used, processing burden. So it's not just a case of looking at your server software itself as far as what it requires, but you also have to keep in mind those different applications that you're going to be running on that particular server. The more applications that you use, the more resources that those applications require, the more hardware you're going to have to be able to throw at that type of problems. You also want to look at the vendor reputation for supporting their product. How long are they going to do it? What's their cycle for sending out updates, security patches, things like that? And then they kind of give you the advice of buying a reliable server. Spend as much money as necessary. In other words, you don't really want to skimp on the server side of things. Why? Typically, that's where a lot of your data resides. Hardware is usually hardware and software, the applications, are usually the cheapest part of your client-server environment. It's your data that's really important. So you want to make sure that that data is protected by using good quality equipment. If If you want to skimp somewhere else. Skimp on some of the clients, because if they fail, you can replace those relatively cheaply compared to a server, and you're not really that worried about data. On the client support side of things, it allows efficient communication, resource sharing. Client supports tasks for creating and managing client accounts, enabling clients to connect to the network, allowing clients to share resources, managing clients' access to shared resources, and facilitating communication between clients. So we're talking about that client-server relationship. You've got to have both of them to be able to work in that environment. So for client-server communication, you go through this login process, and this login process gets handled by a redirector. A redirector is basically a program that takes your login credentials and says, where are you trying to log into? Are you trying to log into the network, or are you trying to log into the local machine? Because it makes a difference as to where you're going to make the comparison of those credentials. Then they talk about file access protocol, and I'm going to skip over that for just a second. So this process of a redirector, when this client goes to log in, the first thing that's going to happen is the client software, the redirector software on this client is going to say, hey, wait a minute, I need to know something. Are you trying to log into the network and request resources from the server, or are you trying to log into the local machine? The answer to that question determines where it's going to make the comparison for those credentials, at the server or back at the client. And that's what you'll, depending on the result of that, depends on what result in where you end up logging in. As far as file access protocol, Windows XP client communication with Windows Server 2008. There's a couple of different protocols, CIFS as well as what used to be SMB. CIFS is the newer version of SMB. And that's what allows you to be able to access files across a network. So it's kind of like a network, kind of like a file system that you have on your local machine. But rather than accessing files on your local machine, you're accessing files across a network. That's what this protocol allows clients to be able to do. You also see a lot of support for a variety of different types of clients to be able to log into servers. For example, most server operating systems will provide clients a client that you can load on a variety of different client machines to be able to log into their server. So for example, you can log in with a Windows machine into a Unix server. You can log in from a Windows machine into a Novell server. These different clients allow that to happen through their client software. In some cases, that relationship between the client software and the server isn't real clean. It's not real smooth. And in some cases, it will require the use of middleware to be able to do that. Middleware is basically a translation program. It's usually a custom program, depending on the client and the server that we're talking about. It may be something that's custom written for a particular situation, or it may be something that's marketed to a variety of businesses that have this similar issue. But essentially, it acts as kind of a translation piece of software. Think about it if you've got you need to do business with a French company and a German company. You need to speak both French and German to be able to have those two be able to communicate with each other, unless they're able to communicate. So in that sense, you're kind of acting like middleware. You're acting as that person that can communicate back and forth. With middleware used, you jumped into a three-tier environment. Client server is just a two-tier environment. What do we mean when we say client server in this sense? We're talking about being able to shift some of the processing away from the server down to the client and share the processing needs from the client and the server. In a three-tier architecture, we're splitting that load amongst three different tiers: the client, the server, and the middleware. We can have multiple servers, and so sometimes you'll hear the term in-tier architectures thrown around. They're talking about additional tiers to that architecture. And it's a way of distributing the workload for whatever application you happen to be doing. You see a lot, done a lot on the web. For example, you might have you've got a client, obviously. You've got a web server. You've got a database server that's often a different server than the web server. So you end up with these multiple servers to be able to provide services to users. So the middleware is going to sit between the client and server to be able to provide that translation. Any questions so far? Okay. So So users and groups. After the network operating system client authenticates, where the client gets access to the network operating system services and resources. Those resources might be the ability to print, for example. It might be access to be able to create a file in a particular directory, delete files, or modify files, things like that. The primary account is the administrator account on a server, unless it's a Unix or a Linux box, and we refer to it the same thing as root. And it's the most privileged account. It basically allows you to do virtually anything. You can delete files that you probably shouldn't. You can make modifications. You can turn logging on or off, things like that. Every operating system has to have one. They're created by default. Now, can you lock yourself out? Yes. Not advisable, but it can be done. But you need to have the ability to log in and administer a machine so that you can do certain things, such as backing up your data the way you're supposed to, creating additional users, things like that. Usernames. Network operating system grants each network user access to files and other shared resources. We can also create what are referred to as groups. So rather than trying to administer individual users, we have to create individual users for those users to be able to log in. But rather than assigning rights to those individual users, which can be very cumbersome when we get into a larger networking environment, the better approach is to create groups. So for example, in a business, we might have a marketing group, we might have a manufacturing group, we might have a finance group. And what we do is we associate the various users with those groups, and then we assign our security protocols to, or procedures or requirements to the group rather than the users. Why? Because there's one place to go to change or modify any of those security settings that applies to all the users that are associated with that group. It makes administering a network, especially a larger network, much, much easier. So to give an example of users and groups, you might have a teachers group with access to a programs directory or programs folder. Teachers might have the ability to read or modify files inside that folder. Students might have the ability to read, but not modify, not delete. We might lock out administrators completely. Whereas over here to grades, teachers have full control, administrators have read and modify. We don't give students any access. I would think we'd probably give them read, but you know, it's just me. We can also nest or create a hierarchy to our group management. We don't have to necessarily have a lot of distinct separate groups. We can start to nest groups. So for example, inside the marketing group, we might have staff and management, because we're going to have some kind of structure within the marketing department that kind of gives us some insight into their various duties. So we can use this, we can nest these various groups within that department, and that allows us to, again, assign security based on the specific types of needs that those distinct groups need. There's also the concept of inherited permissions. That's where when you have nested groups, for example, or you have this hierarchical structure, that the restrictions that you place at one level filter down to levels below that. In Windows, there's usually a checkbox that you can either use inheritance or not use inheritance to the folders that are below that. And it's a good way to, again, try to ease the management instead of having to go into each individual user, each individual file, and create certain security controls about them. You can simply handle it at a higher level that it filters down to all the folders below it. After user and group restrictions are applied, clients are allowed to share network resources. Any questions so far? Okay, so identifying and organizing network elements. Modern network operating systems, similar patterns for organizing information. Organizing that information in terms of users, in terms of various resources, servers, data files, applications. Though there's differences from one operating system to another, they're all, in one way or another, fairly similar. They all use some type of directory which lists those various resources. It associates resources with various characteristics. The date that a particular file was created, when it was last modified, things like that. The protocol that tends to get used the most, or the approach that tends to get used the most, is some type of database to be able to house all that information. LDAP is the protocol that we use to pull that information out of the database. So it's used to access information stored in a directory. A couple of key points about it are the concepts of an object, attributes, and schema. Object is a noun, basically. It's a person, place, or thing. It's a user. It's a group. It's printers. It's things like that. Then we've got various attributes. Those are properties about that object. So as a user, you have a name. You have an address. You have an employee ID. You have certain things or certain attributes that are associated with you as a user. At the same time, objects, something or more of a tangible object, something like a printer, also has various attributes. It has a brand, a model, a location. You want to know where that printer is. It's on the 5th floor of the Hickman building, or it's in Stephenville. If you send a print job to Stephenville and you're here, that probably doesn't do you a lot of good unless you want it to be there for some reason. So keeping track of all that information in some type of directory is a good way to know where those printers are. Schema is a set of definitions, describing the kinds of objects and object-related information contained in the directory. So we'll show up here in just a second. There's a skip ahead right there. Kind of an example of your directory. So you've got user accounts, computers, printers. Those are all the different types of objects that you can keep track of. Within that, you've got a schema. So the object has a name. There's a globally unique identifier, required attributes, optional attributes, syntax, parent relationships, and then other pieces of information that describe and hence define those objects. So schema, two types of definitions, classes and attributes, which is what we were already talking about. Within domains, we can create what's called a container, or an organizational unit. Organizational unit is a logically defined receptacle. It's similar to the concept of a group. Back in the older Windows NT days, for example, you only use domains. That's how you kind of separated groups logically, or organizations logically. Anymore, they've kind of added onto this concept of a domain and through the use of organizational units. This allows you to group additional types of objects. So instead of just grouping individuals, now we can group, say, floors of a building or printers. We can group different things. We're not just grouping users. LDAP is a particular standard for creating directories and contents from trees. A tree is a logical representation of multiple hierarchical levels within a directory. The root, when we talk about a tree with respect to LDAP, doesn't start at the bottom of the tree. It starts at the very top. It's the very tip top of a tree, and it branches out down from that. Once we get to the very end of a particular branch, we end up with what's referred to as a leaf. So in this particular case, we start at the root at the very top, and it branches out. We've got multiple branches until we get down to various leaf objects. The idea behind developing an organizational or a series of organizational units, your directory structure essentially, is that you really need to plan out that directory tree in advance. Because the idea is that if you simply plan for today, that over time, hopefully you're going to grow. Hopefully you're going to acquire other organizations. Hopefully other organizations are going to be interested in acquiring you. It's great if you own stock and you're acquired. But the idea is that you need to be able to plan for future expansion. If you don't, you will certainly set yourself up for some situations. In the book, they give an example of a company named Circuits Now that starts out developing circuits. They create circuit boards. One way of doing that is simply have an organizational unit for Circuits Now in which they have printers, users, and computers all organized together. But what happens if they expand into the future and they want to start developing chips? They want to start developing transistors? It's certainly going to be much more difficult to incorporate in this design. Whereas if they had an organizational for circuit boards with printers, users, and computers, that would allow them to come back later on and create separate organizational units for chips and transistors in the future. So any questions on that? We'll come back to some specific implementations with respect to Windows here in a little bit with Active Directory. It's their version of their version of that. Okay, sharing applications. Shared applications are often installed on a file server. They don't have to be. They can be installed on the client. They can be installed on the server. It really depends on the specific software, how it's written to be run, and what the needs of your organization are. Microsoft Office, for example, can be installed to run from a server, can be installed on the individual clients, which most people are familiar with. The advantage to installing on the server, if there's a patch, there's an update, it gets patched on the server, and then that patch is automatically seen, if you will, by all various clients. Whereas if you install it on all the individual clients, all those individual clients have to update with that patch. So there's pros and cons to both approaches. As far as the licensing types, we've got 3 basic licensing types: user licensing, seat licensing, and site licensing. User licensing is probably the cheapest way to go. It says we've got, say, 25 computers in here. Maybe we're not all going to be on Microsoft Office at the same time, maybe 10. Or maybe we anticipate 10 users on Office at the same time. So we'll buy a license for 10 users in this particular classroom. Even though and then it gets loaded on all the various machines. How do we restrict the use on the remaining machines? Through metering software. What happens then is, as users start to log in and start to use Microsoft Office, that metering software keeps track of that. It says, okay, first person logged in, second person logged in, 9th person, 10th person. The 11th person tries to log in and says, whoa, wait a minute. You've exceeded your license. You're not allowed to use this application until another user finishes that application. That's one approach to try to manage your costs. So instead of having to buy a license for every computer in the classroom, don't buy nearly as many, but everybody has access to it, just not at the same time. Per seat licensing says, you know what, everybody needs to have access to this particular application all the time. Maybe everybody signs on at the same time, maybe they don't, but we don't want to restrict anybody's access. That's going to be expensive, but it's certainly an approach. It's what most people tend to think of when they sit down at a computer, that they think they have access to all the applications on it. That's what most people are probably familiar with. A site license is what you're going to see in large, very large organizations. Somebody like GM, some universities, things like that, where they're going to have so many clients on a particular network or on their group of networks that they want to buy a site license. And that gives them the ability to load that particular application on any and all of their computers if they want. And in very large-scale environments, that makes sense. But if you're a smaller organization, the cost of buying a site license just doesn't make sense. So, which one suits your particular needs? It's going to depend. You have to kind of look at your organization, look at the usage, what do the users require, and then make a choice based on those needs and the cost of the different licensing types. Installing the application on a server, purchase appropriate type and number of licenses, verify server resources. The last thing you want to do is go out and spend money, especially for an expensive application, and then realize your server's not boofed up enough to be able to run it. Install the application, make application available, and provide users access to the application. They say provide users access to the application. If you load the application on a server and you provide shortcuts to all the various users, but they don't have rights to read or write to a particular directory that the application is located, they won't be able to run it. So security becomes an issue with respect to that in some cases. The network operating system is responsible for arbitrating file access. The idea is this right here. Because we now have multiple users all trying to log in to a particular application at the same time, or to run an application at the exact same time, they're all accessing the same application files. They're potentially accessing the same data files. How does that process get managed or mitigated? That's what the network operating system's responsibility is to be able to manage that process, to make sure that each individual user has the opportunity to access their files in a nice, orderly fashion without corrupting files. Any questions yet? Okay, sharing printers. We like to share printers because, well, printers get used a lot. They tend to get expensive if you have one for every machine in an organization. So if we can share them, we can a lot of times save cost in terms of not only the printer itself, but also in terms of managing and maintaining that particular printer. There's several different approaches. Ideally, you end up with a dedicated print server that's going to manage the various print jobs that get sent to the printer. There's different ways to attach the attach a printer to the print server. They list 2 here, and then in the next diagram they actually show 3. You can attach the printer directly to the network itself, which means it has to have a network interface card, so it has to have its own IP address, that type of thing. We can attach the printer directly to the print server itself, or we can attach the printer to a client machine, which is probably the least desirable in a true client-server environment. For a small network, it's probably the most convenient and cheapest way to go. All network operating systems perform common tasks in managing printers. So here's an example of the 3 different types of network printers. We've got one that's directly attached to our media. Again, that type of device is going to have a network interface card. In fact, if you look at the printer over there, that's exactly what it is. You can see the network card that's going to the side of it over there. It's plugged into it, so it receives its own IP address and is recognized as a node on the network. In this particular case, it's attached. Printer's attached to the client itself. It means that client's going to share that printer out to all the other machines. And in this case, we have a dedicated print server that the network printer is attached to. The downside to this approach right here is the client machine has to be up and running. That's not necessarily a real desirable thing. Down here, as far as having a dedicated print server, it really depends on what you have as the dedicated print server as to how convenient that is. In some cases, that dedicated print server is nothing more than a little bitty box that manages. You log into it via a web server or web browser and can manage the print server that way. In other cases, it's a full-fledged computer server operating system. And again, when you have that type of situation, you're almost back like you are with a client sharing a printer. So the ideal situation as far as ease of locating the printer somewhere in the network is probably just attaching it directly to the media. But for small businesses, you're probably going to end up seeing something more like this. As far as installing a network printer, install the printer driver. You have to have the ability of the operating system to be able to communicate with the hardware. That's what the role of the printer driver is. Make sure you've got appropriate printer user rights. Network printers end up appearing as printers in the print folder. So if you have locally attached printers, any of your network printers are just going to show up in the same place. In Windows, there's an addition to the little icon for the printer that illustrates to you that that's a network printer as opposed to a local printer. Similar to the login process, you have a client redirector again that directs the direction of a particular print job. So let's see if they don't show you the graphic there, guys. So basically what happens is when you hit print, the first thing that the redirector checks is what printer are you sending it to? Are you sending it to a locally attached printer, in which case the print job is sent to the locally attached printer? Or are you sending that to a network printer somewhere? If that's the case, then it sends that print job out across the network to the appropriate printer on the network. Managing system resources. Limited server system resources. Ideally, we would have unlimited processors, RAM, hard drive space, but the reality is we don't. And we've got multiple users, so we have to be able to manage all of our resources appropriately so that our users have decent access to the system. That they're not running into situations where they're denied access because the server's not capable of handling their jobs. Modern network operating systems maximize server memory, processor bus, and hard drive use in an attempt to make sure that all the various users' needs are met. And the idea is to accommodate more client requests faster and improve overall network performance. As far as memory, and this applies to Windows 2003, 2008, Unix, Linux, they all handle memory in a very similar fashion. Each has physical memory. Those are the RAM chips themselves that you'll pop into a RAM slot. When you happen to run out of RAM, physical memory, they'll use some type of virtual memory, a page file, a squat file, depending on the text that you're reading it. And that is essentially additional RAM that gets located on the hard drive. What's wrong with that? Why do we not want to use virtual memory? Hard drives fail. Slower is probably the key one. They're slower. It's a mechanical device. You have to wait for a platter to spin around to get to the right spot. You have to wait for a head to move back and forth to get to the right spot. So they're slower. So we want to avoid that whenever we can. How do we avoid that? Increase your RAM. RAM's relatively cheap, especially today. It's not like back when you were going up to 16 meg of RAM. That was expensive. But now RAM is really cheap. Up your RAM. And that'll reduce your reliance on virtual memory. But that doesn't mean virtual memory is all bad. Virtual memory does help you to expand your ability to serve users. So when you end up in those extreme situations where all of your traditional RAM gets used up, virtual memory can step in and provide some additional RAM. It just slows things down as the files that are located in your swap file get swapped back and forth in your RAM to be able to access it. Multitasking is another thing expanded by the network operating system. Multitasking is the execution of multiple tasks at one time. Again, all modern operating systems do this. In fact, it was once upon a time, it was a really big deal. Hey, you had the latest Windows out when you went to Windows 3.1. Ooh, multitasking, it's great. That was a big deal. But now it's kind of expected. It's not really any big deal anymore. Does not mean performing more than one operation simultaneously. What it really is more like is like a juggler. Juggler is a juggler touching every ball at the same time? No. But he's constantly keeping that ball in the air. That's what multitasking is all about. It's moving each process along, going from process to process to process, and coming back to keep those processes moving along. That it looks like it's working on all those various processes at the same time. Process is a routine of sequential instructions that runs until the goal is achieved. A thread is a self-contained, well-defined task within a process. All processes have at least one thread. A process may have more than one thread. But what we're talking about is with a microprocessor, we can only process one at a time. We just do it so quickly, it makes it look like we're doing multiple ones. To be able to do, to truly be able to do multi-processing, we need to be able to throw multiple processors at the problem. And the idea is to be able to improve response time. So instead of being able to only work on one process at a time, now we can work on 2, 4, etc. So it splits the task. The idea is to split the task among more than one processor in order to expedite the execution of instructions. In general, there's 2 different types of multiprocessing, symmetric and asymmetric. The differences are basically, how do we want to split up the load? If everybody in here is working on the project, on their projects together, and everybody worked on the same stuff together to come up with the very best solution, that would be symmetric. We're all doing the same stuff and putting it together and producing a result. If, however, we break it up, somebody does, a logical diagram, somebody does something else, we split it up into individual parts, that would be asymmetric multiprocessing. The result is symmetric tends to be more efficient, especially in heavy loads. Why? Because with asymmetric, we end up with one processor doing a lot of work because it gets assigned one particular task. We have another processor that doesn't do very much because they got a very easy task. So it's not splitting the load up nearly as well. Most operating systems use symmetric multiprocessing for that very reason. We're going to try to cover that. So any questions so far before we actually jump into some of the specifics? Okay. So Windows Server 2008, who's played around with that? You like it? I agree. I like it. I wasn't a big fan of well, I wasn't a big fan of NT at all. 2000, 2003 was pretty good, but I think 2008 does a really good job of simplifying the management process. So it was released in February of 2008, enhanced version of Windows Server 2003. In a lot of ways, it didn't look all that different, but it certainly ran a little bit better. Uses a GUI, which we tend to take for granted if you're a Windows person. When we jump over to Unix and Linux here in a little bit, that's not necessarily a given. We like GUIs, or at least I like GUIs. Certainly beats command line stuff. But the GUI is a graphical user interface. That's what allows you to point and click at various things. Pictorial representation of computer function. Network operating system GUIs enable the administrator to manage files, user groups, security, and printers. You can do a lot of that from the command line. It's just a lot easier using it from a GUI. Server 2008, much better as far as security and reliability. Very good, very robust server operating system. Also supports remote clients, etc. Several different editions. They have Standard Edition, Web Edition, Enterprise Edition, Data Center Edition. Each one is very similar in terms of how it looks and some of the things that it does. You can do a lot. You can, for example, you can serve up web pages on Standard Edition, but the Web Edition has some additional features that are already loaded that help you to do a better job or help you to provide you with additional reports, additional functionality, things of that nature. And each one of them kind of has their own little niche in terms of those types of things. Data Center Edition, for example, is really geared toward being able to provide virtual machines, which you can do with the other editions as well. It is easier, and there's more functionality that you can use with respect to that Data Center Edition. It is a popular network operating system. Addresses most network administrators' needs well. It's an established vendor. Microsoft's not going under anytime soon. What is that? Why is that important? Well, you're going to get updates, you're going to get security patches, you're going to get support. A lot of people understand and know how to use it, which means your support costs in terms of help desk personnel is going to go down. Device and program compatibility, because they are so widely used, virtually every manufacturer of printers, of various applications, writes their software, writes their device drivers to be able to run on the Windows platform. So it's a large market offering technical support. General benefits, several general benefits offers simple user interfaces. Disadvantage, past criticism for performance and security. That's probably very true, that part right there, past. I kind of like Microsoft. Are they perfect? Absolutely not. But on the security thing, they've probably always kind of gotten a raw deal. Being the established base that they have, they're always going to be the target. That's just the reality of having the kind of market share that they have. But the reality is they've always performed fairly well considering how much market share they did have. Because of that type of criticism, their systems have gotten much better than what they were traditionally. So by today's standards, relative to the rest of the market, they are very solid operating systems, both on the client side as well as the server side. Hardware requirements, we need to think about processing power, memory, and hard drive space. They have a hardware compatibility list, which will tell you through these various devices what's compatible with the operating system. They don't go through the process of telling you what's not compatible, but they do tell you what is compatible, unless they've changed that recently. And you can find all that stuff online. Consult prior to hardware purchases, of course. So there's some basic requirements. At least a gigahertz processor on a 32-bit system, or 1.4 gigahertz on a 64-bit processor. Memory, 512 meg RAM. If all you're going to do is play games on your server, fine, do 512 meg RAM. But if you're going to serve up web pages, if it's going to be a database server, you need to bump the RAM up significantly quickly. It would be hard to find only 512 meg RAM anymore. New RAM anyway. Hard drive, they recommend was a minimum of 10 gig of free space, 40 gig or more is recommended. You don't have to have a network interface card, but it's recommended. DVD let's see, required unless the installation takes place over a network, and they require a pointing device, so a mouse. How does Windows Server 2008 handle memory? Well, we've got 32-bit addressing versus 64-bit addressing. Most of us hear about 64-bit. It's significantly faster. It's got a wider bus, so it can address significantly a larger amount of data. And the idea is that because it can address so much more, and we're operating in RAM rather than off the hard drive, it tends to be more responsive. Well, it doesn't tend to be. It's a lot more responsive, a 64-bit machine. The idea is that it assigns each application or process its own 32-bit memory area. The idea of this is having its own separate area, own separate space in memory, so that if an application happens to get hosed, it freezes up, it locks up, or whatever, we can kill that individual program, and it doesn't affect any other program. That may not sound like a big deal now, but it wasn't always the case. It used to be a point in time where, when something like that happened, it killed your whole operating system. You rebooted. Anything you had up and going was lost. So that is a big deal that it runs in its own memory space. Important in Windows Server 2008, install more memory, and that's almost always going to be your default answer. If anything's running slow, install more memory. You can adjust the virtual memory. Right there, it will manage it. It's installed by default, and it's going to run by default that it will manage virtual memory. If you want to change it for some reason, you can. But again, if you see virtual memory being used too much, I would definitely install more memory. Okay, so we talked about the network file system, being able to access files across the network that Windows uses. The file system that it uses on the local machine, the server itself, is NTFS. That's the default. You can use other file systems. Everybody heard of FAT? File allocation table? There's FAT32. There's different file allocation versions. But NTFS was one that came out with Windows NT. And it's a much more secure file system. It's a file system that allows you some additional capability. It allows you to compress files, for example. It provides you with additional attributes so you can identify what's going on with a particular file. It provides much better security. So you're definitely better suited to stick with the default install of using NTFS rather than some other type of file system. Let's see. File system provides methods for organizing, managing, and accessing files through logical structures and software routines. So the advantage: secure, reliable, and file compression. Avoid file compression when you can, because file compression requires not only additional processing power to compress the file, but when you go to read it, you have to decompress it to be able to look at the contents of that file. That takes away processing. As cheap as hard drives are anymore, if you get to the point where you need space, get a new hard drive. Don't compress your files unless you just really can't avoid it. The only time I could think of where compression might be a good idea would be if you happen to have files that are very old that you really know you're not going to access hardly ever. Then you could certainly save space by compressing them, realizing that you're not going to lose much in the way of processing, lost processing, decompressing those, because they're not going to be accessed that often. NTFS is able to handle very, very, very large files. It's also able to, and I don't think they listed that here, also able to have very, very large or long file names, which was a big plus. Drawback: cannot be read by older operating systems. Windows 95, for example, couldn't read NTFS partitions. So, any questions so far? I want to ask Grant one. Okay, so Active Directory is Windows stab at, if you will, of LDAP. It's their directory service that they've created to be able to keep track of all those various system resources that we've been talking about on a network. Printers, users, etc. Originally designed for Windows 2000 server, and has kind of gone through a few different steps through 2003 and 2008. Essentially, with the Windows Server 2008, you've got two different networking models that you can use. You can use the work group model, which is essentially just a peer-to-peer network that we've talked about before, or you can go with the domain model, which is what you're going to see in a client-server environment. So workgroups is just going to be a peer-to-peer environment, decentralized management, meaning we've got files everywhere, all over the network. When we go to back up those files, we have to remember who backed up, or excuse me, who created a file and saved a file, where. Well, we've got to know all that information. They will back it all up. That obviously creates a huge administrative issue. So it's fine for small networks where you don't have a lot of users. It's easy to keep track of that type of stuff. But as that network starts to grow in size, grow in number of users, grow in complexity, the model just really starts to fall apart. It becomes too cumbersome to really administer very well. And that's where the use of the client-server model comes in, and the use of domains. A domain is a group of users, servers, and other resources. They share a centralized account and security information database, meaning that you log in, you're authenticated from that domain controller. So it's used on the client-server network. And the Active Directory is what contains that domain database. It keeps track of all those credentials and various resources, making it easier to organize and manage resources and security. So you might see a domain model that looks something along these lines. You've got a university domain, say Tarleton, break it up by various colleges around the university for a subdomain within the university domain. You may even have subdomains within a particular college. So for the engineering school, you might have a chemistry domain. You might have industrial engineering domain, etc. Domains aren't confined by geographical boundaries. We may break them up by other types of things, marketing, manufacturing, etc., if we want to take that approach. As far as servers on our network, there's a couple of different kinds. There's domain controllers and member servers. Domain controllers are the controllers that are going to keep track of all our authentication information, our various users, their names, their passwords, etc. They're going to keep track of that information. Member servers do not. They keep track of other types of things, or excuse me, they offer up other types of things. Web servers, for example, mail servers, FTP servers, etc. So the issue is if a domain controller, or excuse me, all our domain controllers go down, even though our web server or our member servers may all be up, we won't be able to get access to our network, and as a result, we run into a problem. So the idea is that we need to have more than one domain controller. Then we've got a problem. We've got to keep track of users on more than one system. We have to have a way to make sure that all the users that are on the first domain controller are also represented on the second domain controller. That's where the process of replication comes into play. We have to have a way of replicating one server to the next, so that if one domain controller goes down, the second one comes back up and we still have access to our network. So you see, essentially our network might look something like that, where we've got two domain controllers. They periodically replicate their authentication information, or user information, from one to the next. We might have our various member servers and then our clients. Something else that we can use to try to organize some of our different groups within an organization is OUs, or organizational units. They can hold multiple objects having similar characteristics, and they can be nested. Allows simpler and more flexible administration. That doesn't sound right. The idea is that with groups that we were talking about earlier, we can only organize them based on users, only based on individuals. Well, we may want to group users within a certain area along with printers in a certain area on a particular floor of a particular building, and apply certain security controls to that organizational unit. So that, for example, print jobs can only be done by users in this organizational unit on this floor from 8 a.m. to 9 p.m. or something like that, depending on the needs of our organization. We can start to group all of our various domains and OUs together into a tree or forest-like structure. It's a directory structure above domains. Large organizations will use multiple domains, kind of like what we were just talking about with the university example. A domain tree organizes multiple domains hierarchically, with the root domain at the very top. So whereas you normally think of root being at the bottom of the tree, the way they've mapped it out is it's at the very top of the tree. Child domains branch off from the root domain, etc. A forest is a collection of one or more domain trees. They share a common schema, and domains with a forest can communicate. Domains within the same tree share a common Active Directory database. Why is that important? That means their definition, their schema for a user is exactly the same in terms of the different pieces of information that you have about a user. First name, last name, social security number. Those are things that you will create as part of the schema, and this will be shared within that same tree across all domains. So trees and forests, you might have the university domain as your root domain. Then you've got various subdomains: engineering, communications, humanities, life sciences. Within life sciences, you might have multiple organizational units: biology, professors under biology, geology and professors, zoology and professors, botany and professors. So it's a way to logically group some of your different organizational units. Any questions on that? You could have a whole class on LDAP and Active Directory.
But you can't have Active Directory just in a word group.
Yeah. No, actually, no, I don't think you can. Okay. I was pretty sure you have to have a domain controller to be able to run Active Directory. I'm not positive about that, but I think you have to have a domain controller to run Active Directory. Which, if you're running a work group, doesn't make sense because it will slow you down significantly. The login process slows down significantly. I used to run an Active Directory for a small network and got rid of it for that and went to a peer-to-peer network for that very reason. It just took too long to log in and authenticate.
Does Unix have all this too, the domain?
They do. They have their own version of it. I don't remember exactly what they call it, but they have something that's very similar to it. Yeah. And it's all based on the LDAP standard. The LDAP standard is something. It is a very large. Like I said, there's a whole class that you can take on this. But there's an LDAP standard that basically says this is how the structure should work and the relationships between all the various pieces. And Active Directory is just Microsoft's implementation of that. So LDAP is not anything that Microsoft came up with. It's just Active Directory is their implementation of LDAP. The other, for example, Novell has their own version of LDAP that they run. Unix and Linux, I believe, both do as well. Trust relationships. Relationship between two domains. Anybody ever use Facebook, for example, to log into somebody else's website? That's kind of what this is here. It's where one domain is trusting another domain to authenticate a user. So when you use your login credentials from Facebook, they're trusting that Facebook has vetted you, that you really are who you say you are. Now, obviously, that's not a high secure type application, but it is certainly conceptually kind of explains this. Essentially, Active Directory supports two trust type relationships: two-way transitive trust and explicit one-way trust. So with a two-way trust, the engineering domain over here, somebody can log into this and, well, actually the example they use in the book is you could have a user over here in the engineering domain that has some kind of an issue where they can't be in the engineering building that day. So they're over here in the life sciences domain and they're able to log in, even though this is a different domain. The reason they're able to log in is because they're both parts, subdomains of the university domain. So because they're authenticated through the university domain, they're able to log in and get access to the network. The downside to this is, though, even though they're able to log in, they're able to get access to their files, for example, their home directory. What they don't have access to is local stuff, depending on the security of their resources over here in the life sciences domain. For example, if they want to go print, if that particular user is not authorized to print to the life sciences domain printers, they're not going to have access, not going to have the ability to print to those printers. But they would be allowed to log in and be able to get access to some of their stuff, depending on the security, how security is set up. In an explicit one-way trust, we don't care about the higher level domains, the parent domains. we're going to set up an explicit trust between one domain and another domain, which means when we establish this type of trust relationship, researchers are going to trust any users that's authenticated over here in the engineering domain, but we don't trust anybody up here in the overall university domain or in the life sciences domain, just within the School of Engineering. So it's probably a little bit more restrictive. Any questions? Okay. So naming conventions. Active Directory naming conventions are based on LDAP naming, which is compatible with Internet names, the Internet naming conventions. So it's a complete hierarchical names database used to map IP addresses to host names. Active Directory, collection of objects, names, associated places in Windows Server 2003 and 2008 network. The two namespaces are compatible. So you can have a client in an Active Directory network that is accessible to the Internet. So Windows Server 2008 network object has three different names: a distinguished name, a domain component, and a common name, and then a relative distinguished name, an EPN, and then it talks about WID. So your DC is your top-level domain in the domain of the name of the organization. So in this case, what is it? Trinketmakers.com is going to be the DC. You can have an organizational unit if you want. Then you've got your CN down here, Mary Smith or M Smith, whoever that happens to be. Your distinguished name is when we put that all together. So we have the DC right here. We have, in this case, it's a directory, a folder represented by the organizational unit, and then we have the distinguished, or the relative distinguished name, which is the CN. Setting up and managing a server with Windows Server 2008 really, I think, is a little bit easier than it was in some of the previous versions, because when you first log in, you're presented with a login screen, or with a management screen that basically asks you various questions and allows you to select specific roles that you want for that server. You can also conduct various management tasks and things like that. So you're presented with something like that, and I know it's probably pretty hard to see, but you get some basic information about the server that you're using. You can select various roles up here. You can tell it that you want it to be a DHCP server or a DNS server, and it will install the appropriate packages that you need for that machine to be able to perform those services. It can perform as a web server, it can perform as a DNS server, DHCP, et cetera, et cetera. Like I said, it install all those packages that you need. This also allows you to monitor performance, make backups of your system as you need, things like that, so you can end up troubleshooting or taking care of problems as they kind of pop up. You have an awful lot of things that you can monitor here, and it's something that different administrators will focus on different parts of an operating system. Some will look at memory a lot, some will look at processor usage, some will look at network usage, and different parts, different statistics that are kept about each one of those. And they'll kind of key on ones that they're used to, ones that they're familiar with. So which ones are the best ones to focus on? I can't really tell you that. Like I said, individual administrators kind of have their own preferences for what statistics to look for to kind of cue them in that there's a problem. Okay, so Unix and Linux. Also popular network operating systems. There's a lot of different flavors of both of them that are out there. Unix has been around a long time. Developed in the late 60s, and one flavor of Unix ended up leading to the development of the TCP/IP protocol stack. Most internet servers run Unix. I actually looked this one up because I was kind of curious about this one. It's about 2/3 run Unix and Linux. They didn't break that up as to how much of that was Linux versus how much was Unix, and then the other third is Windows. So I don't know whether it's Unix or Linux, but there's enough overlap between the two that most people would probably tend to throw those together anyway. So I don't know that it makes a big deal, that it's a big deal to make anything out of that. Some difficulty to master Unix. If you like command line, Unix is probably for you. It's a a lot of command line stuff. There are some GUI interfaces that you can now use on some Unix boxes, certainly on Linux, that makes it a little bit more user-friendly to people that aren't as familiar with them. But if you like command line stuff, Unix is probably the way to go. So late 60s Unix operating system came out. It was developed originally by Bell, which was owned by AT&T at the time. AT&T wasn't allowed to make any money off of selling it because of antitrust laws at the time. So what they could do, though, is they could actually make the source code available for a nominal fee. That nominal fee was not to make a profit, it was to cover the cost of distributing the source code. Eventually, this source code, because this source code became available, you started to see other flavors of Unix become available. So this original version was known as System 5. That's what originally came from AT&T or Bell Labs. Berkeley was a big player and very early on in the Unix world. And as a result, you ended up having a Unix flavor from them referred to as BSD, or Berkeley Software Distribution, I believe is the acronym. And they're the ones that actually came up with the TCP/IP protocol stack. So because of that, it ended up being a very popular distribution. In the 80s and even into the 90s, it kind of bounced around in terms of who owned what. You're talking about a very massive operating system that was developed over, when I say massive, I'm not talking about in terms of sheer size. I'm talking about in terms of what it could do, all the various features that it offered, and various resources that it helped users use. And so it bounced around from place to place, and different groups had developed different parts of it. So who owned it? Well, there wasn't a clear-cut owner. Novell certainly owns a significant portion of the rights to it that they've acquired over the years. So as a result, most people might say that Novell owns the rights, but it's kind of hard to really say for sure. Interestingly enough, though, there's another group that actually owns the trademark to Unix. So it'd be kind of like Microsoft owning Windows, but somebody else has the right to the trademark, to their little emblem. So it's kind of a weird thing going on there. So like I said, there's a lot of different varieties of Unix. In the Unix or Linux world, sometimes you'll hear to those flavors or hear to those different varieties referred to as flavors or distributions or distros. But for the most part, they all share a lot of common features. There's a lot of overlap from Linux to Unix or Unix to Linux. So if you get familiar with one, you can usually pick up another one relatively easily. The Unix operating system can be divided into a couple main categories: proprietary or open source. Proprietary is basically like Microsoft is. Somebody owns the rights to that software. They're not going to give you the source code because they don't have to. But what you do get out of that is additional support because they're selling you this product. So it tends to be tested, I don't want to say tested better tested, but it has a concerted effort from a specific organization that you can go back to for support. So it's available only by purchasing a licensed copy from Novell. Vendors that are going to sell this: Apple's Mac OS X is Unix-based. Sun Microsystems Solaris. There's an open Solaris that's available for free. And then IBM's AIX. So the advantages: accountability and support. You bought it from Novell, you have a phone number you can call. They have to support their product. Optimization of hardware and software. If you buy one of those IBM AIX machines, or Sun, they're going to, in a lot of cases, sell you not only the operating system, but they're going to sell you the hardware that it comes on as well. What's the importance of that? The importance of that is that operating system has been compiled on that hardware, which means it tends to run better. It's optimized for that specific set of hardware. Predictability and compatibility. As a corporation creating that software, they tend to have cycles for turning out patches, for sending out updates, things of that nature. That predictability really is beneficial to network administrators, being able to plan upgrades to their networks and plan scheduling, plan maintenance, and things like that. And then compatibility, the various software applications that are written for a particular platform tend to get tested with that platform, and it tends to be very, very compatible. The drawback, though, no source code access. So if you happen to have a very unique situation that you need to be able to modify the operating system source code to be able to address that particular situation, you can't do it with proprietary Unix. And that's one of the downsides to it. Any questions on that? Anybody played around with Microsoft Virtual PC? I would definitely recommend going out there and playing around with Open Solaris or one of the Linux distributions, just to kind of play with it. It's a different way of looking at your operating system. Even with the GUI, it's different. So, they're free, so why not do it? Open source Unix, one of the key advantages is it's open source. That means they make the source code available to you. So if you wanted to make a modification to it, you can. It's not owned by any one company, and so there's no licensing fees associated with it. Open source software is freely distributable software. There's a documentary on Netflix that I was watching the other day about open source, and the concept of open source has been around a long time. The terminology is relatively new. And one of the things that they found was that some of your players early on in free software were going around trying to market it as free software. Well, the reality is when you go into a corporation and you tell them free software, the first thing that jumps into their mind is cheap software. If it's free, it must be poorly made, poorly constructed. That's kind of where the idea of open source came from, was changing the ability to market it so that it didn't have that connotation of being cheaply made, but rather it was, they're trying to create the concept that you had thousands or tens of thousands of developers around the world working to remove bugs and things of that nature from the software. Unix, GNU, BSD, and Linux are all examples of open source software. There's a variety of implementations or flavors, if you will. And one of the big advantages is they tend to run on a lot of different platforms. And so that's a real nice feature of those. Key difference from proprietary implementations are that software license, the ability to not have to pay for access to that software. So as a result, you have a lot of people that want to go that way because it's not going to cost them anything for the operating system. It's great, right? Well, how many people are really good with Linux relative to Word, or relative to Windows? So there's one.
That's the best version that he uses.
Yeah, but there's a lot of overlap between them. So you can be really good at one and probably be pretty good at most of the others. But that's out of, I don't know, 4, 5, 6, 7 people in here, 8 people in here. So percentage-wise, your support costs are going to go up. Your initial payment is going to be lower though. So which one's cheaper? I don't know. But I think at the end of the day, it all kind of comes out probably roughly the same. Although you can find reports on both sides of the equation that are going to say Linux is cheaper or Windows is cheaper. Yeah.
Do you ever see open source taking out like Microsoft and stuff like that?
They've been talking about that for a long time, and the documentary that I was watching actually talked about the impact that the open source community's had on Microsoft, to the point that Microsoft has opened up certain parts of their code to the open source community. So that tells me that Microsoft sees open source as a potential threat in the future. Could something like that happen? Yeah, but it's not going to be anytime soon. But over time, it can certainly happen. Linux is a solid operating system. So, yeah, it can definitely happen, especially as it gets more and more user-friendly. Yeah. A couple of flavors of Unix. I don't know that I would categorize them quite like this. There's Unix and then there's Linux, and I would delineate between the two, and then talk about the multiple flavors of Linux, which there's a lot. But they talk about two flavors of Unix, being Linux and Solaris. Solaris from Sun Microsystems, runs on SPARC-based servers. Open Solaris will run on an Intel processor, so there's certainly some ability to move platforms there. All commercially supported operating systems benefits. Runs intensive applications, so large multi-terabyte databases, really large databases where you've got just a lot of massive amount of data and a lot of processing needs for it. Linux follows standard Unix conventions, very stable and free, which is a big thing about it. And developed by Linus, however you want to refer to him, Torvalds, which is an interesting guy in and of himself. Let's see, all Unix and Linux versions offer host features. A lot of the same stuff that you're going to see on virtually any network server. The ability to serve up IP addresses, firewall protection, DNS services. Everything has to have TCP/IP because everything's connected to the internet anymore. So, let's see, similar to Windows Server 2003 and 2008. Key differences. Unix and Linux operating systems can act as a workstation or a server operating system. When you go to install them, one of the options that you have, depending on the flavor, will ask you the various packages that you want to load. Or in some cases, they'll say, do you want this to act as a workstation or a server? And then based on that, it will load the various modules that are conducive to that particular type of installation. As opposed to the Windows world, where you have a completely separate operating system for Windows 7 versus Windows Server 2008, completely different operating systems. So even though there's a lot of similarity, you can't pick and choose as you're doing the installation. You picked and choose when you originally bought it. So the idea is there's no single right server configuration. There's just not. Which modules do you want to load? Solaris hardware requirements. I don't know that those are all that important to know, the specific ones. The one that I always find interesting is that Linux will load really on a very small, you don't have to have a lot of memory to run Linux. Now obviously the more you have and the more things you're trying to run, you have to bump memory, but 64 meg of RAM, that's been a long time since that was a minimum requirement in the Windows world. Multiprocessing in Unix, same thing as it is in Windows. It's able to support multiple processors, and as a result it can do multiprocessing. Supports symmetric multiprocessing, so multiple processors. Also supports virtual memory, as well as it uses physical memory, but also adds to that using virtual memory. So if you run out of physical memory, you do have that ability to accommodate those additional demands on your resources. But again, it's the same idea. Add more memory if you run into that situation too much. Allocate memory area for each application. Share memory between programs when possible, so it doesn't consume as much memory as possible. You can run it on 32-bit or 64-bit systems. And something you hear a lot in the Linux and Unix environment is this idea of a kernel. A kernel is really nothing more than the very core part of the operating system. It's something that they don't, unlike the Windows world, which tends to give users probably too much access to the inner workings of the operating system, the kernel in Unix and Linux environments don't allow that access. And as a result, a lot of people tend to view Unix and Linux as being more secure, and that probably is, from a security perspective, a benefit to the Linux and Unix environment. File system that Unix uses is a hierarchical file system. We tend to take that for granted in the Windows world. If you go back to the DOS days, I won't say they stole it, but the idea came from Unix. Unix was the first one to have a hierarchical directory structure, and as a result, we tend to take it for granted because it just seems to make sense. Well, it makes sense because somebody developing Unix came up with this idea. So this hierarchical structure might look something like this, where you've got your root directory and then your various folders or directories within the Unix system, and then various subdirectories or subfolders within that. The actual file systems that Unix uses, you can use different file systems. Two broad categories. Remember, we were talking just a second ago, or earlier, about network file systems versus disk file systems. So a disk file system, organizing, managing, accessing files through logical structures in software routines. These are the files that are located on the local machine, so on the server itself. And the disk file system is responsible for allowing that access and showing us the relationship between the various structures, the various files and the various folders on that local system. The native file system for Linux, at least for more recent versions, ext3, there's different file systems. And that's one of the real nice things about Linux is it will work with multiple file systems. So if you happen to have an old fat file system from Windows, you can create a fat file system in Linux and they can read each other. ext, though, tends to be a much better file system in the Linux world. In Solaris, it's UFS. The network file system is kind of like the Windows shares that you have in the Windows world. It's what allows you to access those files across the network. So attached shared files are drives from Windows or other Unix servers to share files with users on other computers. Let's see. Sun Microsystems uses NFS, a network file system. Open source application implementing Windows SMB, CIS file system protocols. It's referred to as a Samba server. It allows you to access Windows files on Linux using a network file, the network file system, a Samba server to be able to do that. Have you used Samba? What do you use it for?
It actually works as you can use it as a set up a Linux box as a server to Windows, and it can somewhat mimic an Active Directory setup, file sharing.
To act as a file server.
File server, print server with cups and stuff like that, and it will do authentication with privileges and stuff like that.
Okay, let's see, just look at that one. Unix and Linux command line sampler. Here's the fun stuff. Okay, so in the Windows world, we're used to a GUI. The GUI really is just implementing a lot of command line type commands through a graphical user interface. In a Unix world, we're really going to be using a shell or a command line interpreter to be able to type those commands in manually. That means you don't have those visual cues that you have in a GUI environment. If you don't happen to know all the various commands and all the various switches, you use man pages or manual pages. Those are documents in a Linux or Unix box that provide information about a particular command. How is that command used? What are the switches? What do the switches do? Things of that nature. Basically, there's 9 different sections of man pages. If you don't happen to know the particular name of a command, for example, you want to type in man and have some a program that you're trying to run, you want to read the manual on that. Well, what happens if you don't know the command? That's where apropos comes in. With that, essentially, you're doing a keyword search on a particular command. So even though you might not get the name right, as long as that name is used somewhere in the man page for that particular application, it'll bring that back up for you and you can find it, read about it. Commands function like sentences, so you end up with basically a verb, a noun, and an adjective to be able to type in your commands. So those rules guide the Unix command use. Significant Unix and Windows command line interface difference is the use of / versus /. It's a / in the Windows world. It's a / in the Unix world. So it looks very similar, but when you're used to one and you look up, you see the other, it kind of looks really funny for just a second before you realize what's going on. So just some of the more common commands, and that's probably hard to see from back there, but if you want to get the current system date, if you want to list files, for example, and then some of the various switches. If you're used to Windows typing in ipconfig, in the Linux/Unix world, it's ifconfig. But you get similar information back about the current IP configuration of your machine. So LS provides file information and stores and file inode information. So ls-l command gives you access permissions field and file type designation. This is what they're listing right here. So if you look at this information, it gives you a lot of information about a particular, in this case, directory, a bin directory. So the first letter right there is a D for directory. That's denoting that it is a directory. If it was a dash, it'd be a file. Then it gives you information about R, W, and X, read, write, and execute in that particular directory. It breaks it down by group, or excuse me, by user, by group, and then all other users. So these first three, or these next three after the D, is the individual user and the rights that they have to that directory, read, write, and execute. The next one is for the group, and they have read. They can't write to that directory, but they can execute files that are within that directory. And then all other users have the exact same order: read, they can't write, and then they can execute. And so that's just kind of how you read that information. You can also, another useful feature in Unix or in Linux is the ability to pipe. And the idea behind piping is to be able to take the output of one command and use it as input for another command. So for example, you may want to list the directory contents of a particular directory and then send that content to a printer. So you can take the output automatically in one command, take that output from the list directory to send it directly to the printer. And then that goes through what we just got the title. So this chapter, we're talking about characteristics common to all network operating systems. If you look at a lot of the Unix stuff, Unix and Linux stuff, a lot of it's very similar to the Windows server stuff in terms of how it handles memory, virtual memory, for example. A lot of the features that are offered, there's a lot of it that's very similar. How you go about using it, obviously there's some subtle differences from the GUI, but from a command line perspective, Unix and Linux are, to be kind, probably a little more difficult to use. But they're certainly very robust operating systems. I guess that's pretty much it for that chapter. Any questions over that chapter? It's really a pretty good chapter. It's a long one.